So here I'm going to show you how to make a regression model. It's a model that we're going to use to predict an outcome. So let's suppose I wanted to predict the amount of your runtime in seconds from your push-ups and your age. So I'm going to take these columns out of here and put them on a different sheet. You won't have to do that with your data because I already cleaned up your data. But here's age. Let's take push-ups, raw push-ups. Put them here, and then put raw sit-ups, and I put in zeros for the ones that have profiles. We talked yesterday about the validity of doing that, but I'm just going to do that. This is just to demo, and my outcome is I'm going to actually predict your runtime. So I'm going to go here and plot that. And so this is terrible data to do this too, but let's do this. Now, to actually run this, you go to click the data, click data analysis, instead of solver, click that, and you're going to select regression. Hit OK. The first is that you're going to pump in your Y values. So my Y values, and I'm going to make sure this labels is selected because that means I have headers and I want those headers to be in the outcomes. So I'm going to highlight the seconds, and that gives me this as my Y range. My X's, I want all these variables to be input variables into my model. We call them explanatory variables. I'm going to highlight that, and those are going to be my input variables. And then I just hit OK. And that gives me this information. So how do you interpret this information? Quickly, adjusted R-square is a measure of how good a fit you have, or R-square. And this is not good actually, that I got a negative one here, but this tells me about 50% of the variance can be explained by these variables, by these explanatory variables. So this is a pretty decent prediction. However, this is a very small data set. You're not supposed to do this with small data sets. I'm just demoing this for you. Down here is your model actually. How do you write out your model? Well, the thing I'm trying to predict is your runtime in seconds. Runtime is equal to, and I just take this value, here's the intercept, so 1309.432. Let's put 3, I'm going to round that, plus, and it's a minus because I have a negative age, 2.645 times age, plus, and there's a minus again because it's negative, 1.99, I'm going to 1.199, I'm going to round that up, times push-ups, plus, all right, so again, minus 1.73 times sit-ups. So the more, what this is saying is that the more sit-ups I have, my runtime is going to decrease. That makes sense to me because this is a negative coefficient. Negative also on the push-ups. The more push-ups I do, the lower my runtime. So that makes sense to me. Higher my age, the lower my runtime. That doesn't make as much sense to me. But that's what my model's coming out to be saying. Now, over here, we have a very important column called p-values. And none of these p-values are small. For these variables to be significant predictors of my outcome, the p-value should be below 0.05. None of these are below 0.05. And there's a lot behind all of this, and you're going to learn about it in 206. But for your model that you're going to do with the letters of recommendation, these things are going to be lower. Some of these are going to be lower than 0.05. And so I'm going to ask you to pick those out. So now you're going to examine the same thing with the letters of recommendation data.